In this video, I will show you how to solve this problem everyone is clickbaiting with. So x plus y is equal to 6 and x multiplied by y is equal to 36. If you observe the first equation of this system of two equations with two unknowns, the idea that comes to mind is to express the variable y in the terms of x. So that is going to be y is equal to 6 minus x. If you then take this newly obtained information for y and apply it to the second equation of our system, it gets transformed into x multiplied by 6 minus x for y, and that is equal to 36. This equation, x multiplied by 6 minus x is equal to 36, is equivalent to 6x minus x squared is equal to 36, which is again equivalent to x squared minus 6x plus 36 is equal to 0. The only thing left to do now is to solve this quadratic equation, and we can do that by using quadratic formula. Remember that for the quadratic equation ax squared plus bx plus c is equal to 0, quadratic formula is x1 or 2 is equal to negative b plus or minus the square root of b4 b squared minus 4ac divided by 2a. In our example, a is equal to 1, b is negative 6, and c is 36. So x1 or 2 is going to be negative 6 plus or minus the square root of negative 6 squared minus 4 multiplied by 1 multiplied by 36 divided by 2a, which is 2 multiplied by 1. So this is equal to 6 plus or minus the square root of 36 minus 144 divided by 2, and that is 6 plus or minus the square root of negative 108 divided by 2. In order to calculate this square root, we are going to calculate the canonic factorization of the number 108. So 108 is divisible by 2, after which we get 54. Again, that can be divided by 2, and the result is 27, which can be divided by 3. The result is 9, again by 3, this is 3, and 3, finally we get to the 1. So number 108 can be written as 2 squared multiplied by 3 cubed. Therefore, x1 or 2 is going to be 6 plus or minus the square root of negative 2 squared multiplied by 3 cubed divided by 2. So this is then going to be equal to 6 plus or minus the square root of negative 2 squared multiplied by 3 squared multiplied by 3 divided by 2, which is going to give us the result of 6 plus or minus I multiplied by 2 multiplied by 3 square roots of 3 divided by 2. And that is 3 plus or minus 3i square roots of 3. So we have the solution for the quadratic formula. The solution is x1 is equal to 3 plus 3 square roots of 3i, and the second solution, x2, is equal to 3 minus 3 square roots of 3 multiplied by I. Remember that we had a connection y is equal to 6 minus x between x and y, and using this connection we get that y1 is equal to 6 minus x1, which is equal to 6 minus 3 plus 3 square roots of 3I, which is equal to 6 minus 3 square roots of 3I, which is giving us finally 3 minus 3 square roots of 3I. y2 is equal to 6 minus x2, which is equal to 6 minus 3 square roots of 3I, which is equal to 6 minus 3 plus 3 square roots of 3I, which is equal to 3 plus 3 square roots of 3I. So there are two solutions of our original problem. x1, which is 3 plus 3 square roots of 3I, and to that x1 corresponds y1, which is 3 minus 3 square roots of 3I. This is the first solution, and the second solution is x2 is equal 3 minus 3 square roots of 3I, and corresponding y2 is 3 plus 3 square roots of 3I. For additional practice, let's check if the obtained solutions are correct. We are going to do that by plugging in the results for x and y into the original problem. The original problem was x plus y is equal to 6 and x multiplied by y is equal to 36. So, by plugging in the results for x1 and y1, we get the first equation x plus y to be equal to 3 plus 3 square roots of 3I plus 3 minus the 3 square roots of 3I, and these two can cancel out, so we get the result of 6, which is here the expected result. So this equation holds true. Let's now check if the second equation is satisfied. x1 multiplied by y1 is equal to 3 plus 3 square roots of 3I multiplied by 3 minus 3 square roots of 3I. And this is equal to 9 minus 9 square roots of 3 squared I squared, which is equal to 9 minus 9 multiplied by 3I squared. So this is 9 minus 27I. And remember that I is equal to negative 1. So this is finally 9 plus 27, and that is going to give us the result of 36, which is exactly what we have needed. So the second equation also holds true. So both equations of our system are satisfied, and that means that we have correct solutions. So thank you for watching, and I'll see you in another video.